Okay, so now we're into our last chapter, chapter 11 of the textbook. So talking about sequences. So here's our kind of formal definition here. Um, and I think it's perhaps easier to, just think of a sequence as being a set of real numbers that are in a particular order. So something like, so an is equal to, let's see, n over n plus 1. Okay, notice here I'm using a slightly different notation. This one's also very common. Okay, so you have A1. Okay, this will be the first term of the sequence. You get 1 over 1 plus 1. Okay, just replacing n equals 1 here. And so we get 1 over 2. A2 is going to be 2 over 3. A3 is 3 over 4. Okay, so maybe you want to write this as an is equal to a half, 2/3, 3/4, 4/5, dot, dot, dot. And we can put what's called the general term like that. So I think of a sequence as being a kind of a set of real numbers in a particular order. Okay, we have the, n equals 1 term, the n equals 2 term, the n equals 3 term, the n equals 4 term, and we list them left to right. Okay, so why don't you pause your video after I write this exercise. So list the first 5 terms of an is equal to -1 to the n squared. Okay, pause your video now, give that a try, and you can unpause it whenever you're done. So what I'm going to get here is, well, an is equal to, well, the first one, I plug in n equals 1, it's going to be giving me a negative. Okay, so this is what is called the kind of alternating factor. It's going to be -1 or +1, depending on whether n is odd or even. Why can't I write a plus? +1. So that comes up a lot, so make sure you're on top of that. So -1 to the n is, -1 if n is odd, and it's going to be +1 if n is even. Okay, so back to my list here. N is equal to 1, that's my first term. I get just -1. And the next term is going to be positive, right? And then I have 2 squared, which is 4. And then I have 3 squared, but now minus. And then I have 16 minus 25. And that is 5 terms. Okay, so this is listing terms of a sequence. Why don't we instead go backwards? Which is more interesting, is to take a sequence and find the general term. So find an expression for an. This is called the general term of the sequence. A. Sequence here is going to be 1 minus 4, 9, 9 minus 16, dot, 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 dot. B, 2, 4, 6, 8. C, 1 over 7, 8 over 9, 27 over 11, 64 over 13. Dot, dot, dot. Okay, an assumption here. I'm going to say these, we're going to assume that these follow the most obvious pattern. Okay, if you think too much about this, you will convince yourself that the most obvious pattern is not the only possible pattern. But we're not going to think so much. Strange thing for a math teacher to say, but let's just take these at face value. Okay, first one. So this is a bit of a guess and check here. What do I have for part A? I have power squared. The squares, that's 1 squared, 2 squared, 3 squared, 4 squared, right? So I'm going to go ahead and put n squared there because I notice these squares happening. Now I have to adjust here. That's what I mean by guess and check. As it stands, this is not correct. I have to account for that minus sign that's appearing when n is even. Because remember, we have, n equals 1, n equals 2, n equals 3, and so on and so forth. So when n is even, we want a negative. So we have to go -1 to, well, not just n, we're going to need n plus 1 will work. Or n minus 1, doesn't matter. Okay, next one. These are even numbers, so we just get 2n. So that's my kind of my guess here. And to check, I would say, well, this is the n equals 4 term, right? Oh boy, going crazy. Now I ask myself, when I plug n equals 4 into here, do I get 8? And the answer is yes. So I make that little check, 2 or 3 times, convince myself that my expression is good. Okay, next one. Next one we have kind of 2 pieces to this puzzle. So I'm going to separate this. I'm going to say, let's talk about the numerators first. What's happening here? I have 1, then 8, then 27, then 64. These are cubes, right? That's 1 cubed, 2 cubed, 3 cubed, 4 cubed. So it looks like I have n cubed on top. And on the bottom, what's happening? 7, 9, 11, 13. That's going up by 2 each time, right? 7 to 9, that's 2. 9 to 11, that's 2. 11 to 13, that's 2. So for this reason, I'm going to go ahead and just go 2n. I'll put it down here, 2n. Now that's obviously not quite right on its own, but I can adjust this, to match, say, the first term here. N equals 1. So how can I fix this guy down here so that when I plug n equals 1, I get 7? Well, I'm going to have to throw a plus 5 here to fix it. Okay, so I hope I'm explaining my thought process there. It's really a guess and check, I start with kind of pattern recognition. I write something down, I adjust it, and I keep on adjusting until I am convinced that I'm on the right track. Okay, let's write down an exercise here, and then we will move on to the next video. Okay, exercise. So we'll say same cue as above, but hey, oh, lose my notes here. Where are they going? Oh, -1, 1. Oops. Come on. Come on. Oh. 1, -1, 1, -1. Dot, dot, dot. B. 1. Root 8. Root 27. Root 64. And finally, 1 over 9, -1 over 12, 1 over 15, -1 over 18, dot, dot, dot. Okay, we will pick this up in the next video.